Okay, so we are here and we've been doing a lot of work with segments, but now we're going to start to work with angles. And this goes very quick because we're doing the exact same thing with angles that we did with segments. We have to name them, measure them, add them, bisect them. So we're going to do the same things, but it all happens right here, right now. So let's do it. Naming angles. So we name an angle typically using three letters. I'm going to trace the angle. And again, watch how I trace it because that's the way we trace it is they're going to give us the name. I want to start on one side. I'm going to go through A. I'm going to get to B, the vertex, change direction, and then go out to C. So notice I went A, B, C. Now I could have gone the other way. I could have started with C and go through C, through B, and then to A. So angle CBA. That's how we name an angle. We use a point from one side, the vertex, which is the point where it changes direction, the point of it, where it makes a V. So a point from one side, the vertex, and then a point from the other side. And that's how we name an angle. So we used a little angle icon in front of it. And we can call this angle ABC or angle CBA. That little icon matters because without it, are we just talking about the three dots, A, B, and C? Are we talking about the plane ABC? Are we talking about the angle ABC, the triangle ABC, the arc ABC? We have to know what we're talking about. So that little icon of an angle is very important. Now, we can call it angle ABC, angle CBA, or finally, in this example, we could call it angle B. And the reason is because there's only one angle that comes out of point B. For example, if our picture looked like this, and that was point B, you wouldn't know which, if I said look at angle B, you wouldn't know which angle I'm talking about. There's the little angle on the left, there's the little angle on the right, but there's also the big angle that includes both of them. So we can't do this. We can't do that. We can only use the vertex letter by itself when there's only one angle coming out of it. So we try to use three letters. Sometimes what they'll do is they'll give us a little reference number inside of it, and we can call it like angle 1. Right? So they might put a little number in there, 1, 2, 3, and it's a reference. So it's like a nickname or a shortened name. The other thing you'll notice is sometimes, and usually this is with handwriting, people like put the little arc in it. So that way it doesn't look like a sloppy L. You put the little arc. Now that's personal preference, but you'll see it both ways. So I'm showing it to you now. That all means the same thing. And again, that 1, it's not the measurement. It's just a reference, a short name for it, a little nickname. When it does come to measurement, we're going to figure out the measurement of angles, and we just put a little m in front of it all. But let's talk about classifying angles. There's 4 different kinds of angles that we'll be working with. Acute angles measure between 0 and 90 degrees. A right angle is exactly 90 degrees. And sometimes, to tell us there's a right angle, we'll see a little box in the corner, that right angle indicator. And we've seen that like in right triangles. An obtuse angle measures between 90 degrees and 180 degrees, and a straight angle measures exactly 180 degrees. Everything we're doing right now is in degrees. So the units are very simple, very consistent. And nothing that we're doing goes past the 180 degree for an angle. They do exist. We're just not doing those right now. So we're asked to do a few things here. We're asked to name and classify some of these angles. So in number one, it certainly looks more than 90. So I might say obtuse. And I might call it angle RTS. I could also call it angle R, angle STR, or even just angle T. In number two, we know it's a right angle because of the little box. So it's a right angle. And maybe we'll call this one angle LZB. Number three is a straight angle. And again, if we think of J as the vertex, the hinge, I might call this NJC. So angle NJC. Again, I could reverse that. Angle CJN. Number four is an interesting one. Let's look at number four here. We were asked to name and classify the angles. Well, first of all, think about how many angles you see in number four. I see 3 angles. So let's go through those 3 angles. First, I see this angle right here, which to me looks acute. A little bit less than 90, but again, we're not measuring it. And I could call that angle YDK. I could also call it angle KDY. That'd be fine. But I cannot call it angle D because look right next to it. Here's another angle that uses D as the vertex. So if you said angle D, nobody would know which one we're talking about. Here we have what looks like an acute angle. And we can call that angle KDL. Now, these two angles are considered to be adjacent to each other. Adjacent just means next to each other. And they share the vertex. So again, adjacent means that they're next to each other. They share the vertex and the line that separates them. And that's it. They don't share anything else. So these are considered to be adjacent angles. And adjacent is really important. When segments were adjacent, we were allowed to add them. When angles are adjacent, we're allowed to add them. So understanding that these are adjacent angles, they share the vertex, the line that separates them. That's it. But finally, just to finish this question, we also have this big angle, angle YDL. So we have this obtuse angle, angle YDL. And of course, we could have named it LDY. But again, if we said look at angle D, you wouldn't know which of those 3 to look at. Now, since we're looking at this picture, look at that carefully. The purple angle is made up of the blue and the green. In fact, if you think about this, the blue plus the green together make up that purple angle. We're going to come back to this idea in just a minute. But when we work with angles, we draw little arcs in them. So the blue one and the green one right there. And notice that one arc just runs right into the other. That happens when they're adjacent. Again, adjacent angles share the vertex, in this case point D, and the line that separates them, in this case ray DK. And when that happens, we will be allowed to add them using angle addition. Okay. So again, here we were just asked to name and classify, but I'm showing you that because we're going to get to that very, very quickly. All right, well, we're asked to name a few things or identify a few things. So let's see what's happening here. We're asked to name a right angle. Well, look for the little right angle box. So maybe we can name it angle JSL. Or I could have done something like JSW. So from J down and to the right. Or I could have gone down to S and to the left, JSW. And there's other right angles, for example, angle YLG. We can name an obtuse angle. So we're looking for something that looks bigger than 90 degrees. So if we find something that includes 90, but it goes bigger, we'd have it. So since we don't have any measurements, maybe we can do something like, we know that Y, L, we know up to G is 90, but what about out to P like that? That would be an obtuse. So something like angle YLP. And there are several. We're just picking one or two to look at here. We could do, sorry. What about something like angle JRL? That's definitely more than 90. So angle JRL. There's a handful of them here. I'm just trying to give you guys a little bit of an example. Number 3, we're looking for an acute angle. So an angle that is definitely less than 90. And there's some that certainly look it. Let's see. What if we did YLW? That's less than 90. So that'll work. Angle YLW. That's a good one. How about angle KLG? That angle right there. And again, remember, we draw an arc in it. That's less than 90 also. Angle KLG. Okay. And there's a bunch. There are a bunch of angles here. How about a straight angle? So again, we need a vertex, and it has to go out on both sides. So we could do something like S is the vertex. One side goes to W and the other side goes to L. So angle WSL. We could have picked a different one. Here. We have J. One side goes through, we have R. One side goes through J. The other side goes through S. So that's another straight angle. Maybe we call it angle JRS. So there's a bunch. Classifying angles. Remember, acute, right, obtuse, straight. So let's find the angle. Trace the letters in order. WLG. So WLG. And that's definitely obtuse. Now, we don't have measurements, but look at it. It includes this right angle, and it goes past it. So it goes to the right angle and past it. So it has to be more than 90. So even without numbers, we can reason this out. Angle JSP. JSP. Well, again, look at that. Look right for the vertex. There's a little box. So what does that little box tell us? It's a right angle. And PLG, let's see, PLG, that certainly looks acute. Okay. So we can name angles and we can classify angles.